the same, it's always equal to each other.
Yeah, these exponents. As long as there's not like a +1 hanging out somewhere, because that throws everything off.
All right.
Okay, and yes, now I subtract 3x from both sides. This gives me positive 3x equals positive 3, so x equals 1. This is hopefully a pre-algebra / algebra 1 type equation from here. But it all comes down to seeing that they have the same base.
So,
Wait, that's the answer, actually?
Yeah.
if they have the same base, you can drop the 2.
Yes. You can also do this with logarithms, but really it only helps you.
Okay, well,
A calculator won't help you on this. Doing this with logarithms,
if you wrote that as a logarithm, it would be log base 4, 3 equals x.
okay, well if that's the problem with this, you can't rearrange one exponent equal to another exponent into a single logarithmic equation. Well, you can, but that would be really ugly. Here's what you'd have to do this with logarithms, okay? You'd have to still realize that 4 is a power of 2 and 8 is a power of 2. And that hint would tell you to take the log base 2 of both sides. That hint would tell you to take the log base 2 of both sides. Then you would whoosh down the exponents. Okay? And this is the point where you'd realize that the reason why you did the log base 2 is because you know that the answer to this. The log base 2 of 4 says what power do you raise to what power do you raise the number 2 in order to get 4? 2 to the what power is 4? 2, yeah, I know I was asking that question too complicated. 3x times 2. And 2 to what power gets you 8?
3.
3. Jordan?
So
Whatever it is, it can wait. Okay? So this becomes 6x equals 3x plus 3. And then you solve it from there.
And you do the same thing.
Yes. So using logarithms here really only works if you already know that 4 and 8 are powers of 2, and if you already know that, I think this way is easier. But if you like this way better, that's fine, but you've got to recognize which base to use.
Wait, that's the exact same problem we did 2 minutes.
Yep, 2 different ways.
Oh, you just added log.
I did it once just by recognizing a property of exponents, and I did it again by recognizing that log base 2 was the way to go.
Oh, no, thank you.
Actually, yes, this one just has something with the first choice. Is that okay?
That's totally fine. I prefer this way.
Even
Some
though
people,
there's no log or anything?
yeah, that's fine. The title of today's is Exponential and Logarithmic Equations. This is an exponential equation. Okay, there's another property of logarithms I have to teach you that may come in handy on some of these. Well, actually, I'll give you first an easy one, and then a slightly harder one. This one is meant to be fairly easy. Thank you, Becca. If the log base 3 of x plus 5 equals the log base 3 of 12.
You divide it.
You know, you're probably about to say, you probably have to work out the right step, but divide's the wrong word.
Because x plus 5 over 12.
What do you think is going to be the next line, Jordan?
Log 3 parentheses.
Actually, we don't even need that one.
Hold on. Will it be 3?
X plus 5 over 12.
No, this isn't subtraction.
Okay.
That only works if this is subtraction. That's an equal sign. Okay? Here's what we're going to observe. Okay? I'm going to teach you this one by observation. If the log base 3 of one thing equals the log base 3 of another thing, what do you think is true about those two things?
They're the same.
They have to be the same for this to be true. And if x plus 5 equals 12, what does x equal?
Wait, so you're saying
You can drop the logs in this case. You can drop the logs. Now, what'll totally mess this up, if I put like a +1 out here, then you can't use that trick, and then you're done.
Would 4 be your answer on the other side?
Pardon?
Would 4 be your answer on the other side?
No, this does not multiplication. This is 3 to raise to what power equals 12.
Is that your answer then, or are you done?
Yeah, now you're done.
It's in between 2.
So they have the same
Yeah,
log
you don't even want to go
base.
there. Yeah, if they have the same base, you can drop them entirely. If everything on one side of an equation is inside a
And then
logarithm,
you undo the parentheses and solve it.
yeah, then you just boom, drop it.
So that's your answer?
Yeah. You can drop the logarithms if they're the
Oh,
same
right,
base.
they're the
Hold on,
same
if they're the same base, and if they encompass everything on one side and everything on another. If I were to put like a +5 out here or something, this method wouldn't work. You can't drop it then. And it's not dividing by them though, Jordan. That's a slight incorrect way to say it. But that's one example. Now here's another example, last one. If I have log base 3 of x plus 5 equals 12 without a logarithm there.
Could you still do it, or would you have to keep the log?
You have to keep the log. You can't just drop it from one side, and it's not like dividing or multiplying it. So this is more like a square root sign than anything else you've seen.
Can you like put a log there on the other side?
Well, here's a trick. Here's a trick to this.
System.
New trick up here.
Really?
If you have a number, and it's raised to an exponent, and inside that exponent is a logarithm of the same base. If you have a logarithm in the exponent spot, and it has the same base as the big number down here, the this operation actually cancels out the logarithm. So if you have a number raised to a logarithm, and the bases are the same, they cancel each other out, and you're left with whatever you were taking the logarithm of. Okay, that's a new trick. You can use that to get rid of a logarithm. This number is too big for this problem, so here's what I can do. I'm going to take both sides of this equation, and I'm going to make them exponents with the same base. Okay, I'm going to make these into exponents above the same base, and that base is going to be 3, because that's the base of my logarithm. So this is going to be 3 raised to the log base 3.
That is a big 3.
X plus 5, I want to make a big point, equals 3 to the 12th power.
Really?
Yeah.
Where'd you get the 3 from?
I chose 3 because it's the same base as my logarithm, Sade. That's the only way this canceling trick will work.
I can't.
Okay? Now, this 3 raised to the log base 3 of x plus 5 cancels out, and my next step is just x plus 5 equals 3 to the 12th. So x equals 3 to the 12th power minus 5. I should have picked a lower exponent because that number's huge. That number's so huge your calculator might have trouble with it.
Wait, so you can cancel that and read the log?
Yep. But to do that, I had to raise both sides of the equation into the exponent spot with 3 as the base. Same base as the logarithm is the only way that works.
No, I got the answer.
All right, this is going to take some practice. Okay?
5, 3, 1, 4.
There's further examples in the book, and the homework is...
None.
Oh, there it is. Right.
Is it on the internet?
It is.
Well, that was fun.
If you don't have... okay, Becca, go ahead and kill the recording now.